Unit 1, Lesson 1, Adding, Subtracting, and Multiplying Polynomials. So recall that a polynomial is a collection of at least two terms, and these terms are added or subtracted together. Now, as a review from grade 10 math, remember that when you are simplifying polynomials, you can only add or subtract terms that have the exact same variable, and those variables have the exact same exponent. So you could add or subtract a squared with 2a squared, but you could not add or subtract a squared with 2a cubed. Okay, we'll review all this now, but keep in mind this is a review of what you learned in grade 10. Okay, so example 1, let's simplify this polynomial. So what I like to do is I like to group all of my like terms first by circling them off. So we have a 3ab squared. Now let's circle any other terms that have a variable identical to that. So they also have an ab squared. So that's only this guy. Now let's look at him. So he is positive 8a. So let's square off any other term that has just an a as their variable. Okay, and finally the last two terms remaining are not like terms, so there is nothing that we can combine them with. Okay, now let's go ahead and combine the like terms. So 3ab squared minus ab squared is 2ab squared. Okay, so you notice you just kind of subtract the coefficients. So it's 3 minus 1 is 2, and then you write down your variable, which is ab squared. So you don't really do anything with the variables once they are grouped. Okay, now let's combine our other set of like terms. So the 8a plus 13a, which is 21a. Okay, and now let's just write down our last two terms because there's nothing we can combine them with. Okay, part B, let's simplify this. So we have a little bit of work to do before we can collect like terms, right? Because we've got some brackets there. So let's use the distributive property to expand or to get rid of these brackets first. Then once we get rid of the brackets, we can then combine like terms. So just always scan your polynomial first. See if there's any expanding that needs to be done before you start to collect the like terms. Okay, so we gotta use distributive property here and here, and remember that's technically a negative 1. Okay, so positive 2 times 4x is 8x. Positive 2 times negative 7 is negative 14. Negative 1 times x is negative x. And negative 1 times negative 6 is negative 6. Okay, now let's group our like terms. So we have terms with a variable x, and we have terms that are just plain numbers. Okay, constants with no variable. So we have two groups here. So I'll circle all of the terms with an x to the exponent 1. They're like terms. And I'm going to square off the constant numbers. Okay, now let's add together our 3x plus 8x minus x, so that's 10x. And now plus 1 minus 14 minus 6 is minus 19. Okay, and now just to make sure that you're done the question, there's no more simplifying that can be done, you just scan the equation from left to right, and if there's no like terms, you're done. Okay, we're now going to review multiplying polynomials. Again, this is a review of grade 10. Remember that when you're multiplying polynomials together, sometimes our exponent rules come into play. Okay, so let's quickly review the product rule. So the product rule states that when you're multiplying two terms together that have the same base, the same variable, right? These guys both have a base of x. What you do to multiply them together, you keep the base, so you just write down the x, and then you add the exponents together. So you'd add 2 plus 3. But to multiply these guys together, you're going to keep the base, add the two exponents together, and there's your answer. Okay, so quick review there of the product rule. Let's go ahead and try our first example. So let's simplify this expression here. So we have 2 minus 5y times x plus 3. Okay, so we're going to use FOIL here. So I'm going to go 2 times x, which is 2x. 2 times 3 is positive 6. Negative 5y times x is negative 5xy. Okay, remember we can't do anything with that x and y because they're not similar bases, right? One's a y and one's an x, so we can't use the product rule on it. And then negative 5y times 3 is negative 15y. Okay, now let's combine like terms if we have any, and unfortunately here we do not. We do not have any terms that have identical variables and exponents, right? This guy's got an x. This guy doesn't have a variable. This guy's got an x and a y, and this guy's just got a y. So we have no like terms here. Okay, so because there's no like terms here, we are finished. All right, let's try example B. So example B, let's scan this expression. All right, so example B, let's scan this expression and see if there's expanding that needs to be done before we can collect like terms. There is, right? We've got some brackets. So let's go ahead and use the distributive property to eliminate these brackets. 4x times x, and remember these x's have little exponent 1s on them, right? If it doesn't have an exponent there, it's an exponent 1. You can write that in if that helps. So 4x times x is 4x squared. Okay, 4x times 1 is just 4x. Negative 3 times 5x is negative 15x. And negative 3 times negative 7 is positive 21. Okay, now let's combine any like terms. So 4x and negative 15x are like terms. Okay, scan it from left to right. We are finished because there's no more like terms, and our terms are in decreasing order by degree, right? We've got a x to the power of 2, an x to the power of 1, and then just a plain number. So that's perfect. Okay, let's simplify this. So obviously we have a binomial times a trinomial. And this might freak some of you out because you're used to just using FOIL when there's two binomials being multiplied together, right? But now that we have that 3-term polynomial, it might look a little tricky to some of you, but don't worry, it's the same thing. All I'm going to do is I'm going to take my first term here, 4x, and I'm going to multiply it by each of the 3 terms in the second set of brackets. So that is FOIL, right? It's just in grade 10 you guys were used to only having to multiply it by 2 terms in that second bracket. Now we're just multiplying it that 3rd time. Then you're going to take your second term and you're going to multiply it by each of the 3 terms in the second set of brackets. Okay, so let's go ahead and do that. So 4x times 2x squared, multiply the 4 and the 2 first, you get 8. And then the x times the x squared is x cubed. Now let's do 4x times 5x, so multiply the numerical parts first. 4 times 5 is 20. X times x is x squared. And finally 4x times 2 is 8x. Okay, now let's multiply that positive 3 times everything in the second set of brackets. So positive 3 times 2x squared is 6x squared. Okay, positive 3 times 5x is 15x, and positive 3 times 2 is plus 6. Okay, let's circle off any like terms. So we have 2 terms that both have an x squared, so those guys are like terms, and we have 2 terms with just an x to the power of 1, so those are also like terms. Okay, so let's just quickly combine those. Okay, to determine if we're finished or not, just quickly scan the equation from left to right. And there's no more like terms, which is great, and the terms are in decreasing order by degree. Okay, part D. So we have distributive property that we need to do first. We need to distribute that 4 amongst everything inside of the first set of brackets. Then we also need to expand this. Okay, we've got an exponent of 2 on the outside of that bracket, so we basically need to replicate that bracket. Let's go ahead and do all this. So 4 times x squared is 4x squared. 4 times 3 is 12. Okay, so now I'm going to expand this. So 2x minus 1 all squared just means take 2x minus 1 and multiply it by itself twice. So now let's go ahead and use FOIL to eliminate these brackets. So 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. Negative 1 times 2x is negative 2x. And negative 1 times negative 1 is positive 1. And now let's collect our like terms within the brackets. So the negative 2x and the negative 2x turn into negative 4x. And some of you might be able to skip that step, which is totally fine. Now let's distribute the negative 5 and multiply it by everything inside of those brackets. And this will eliminate our brackets. So negative 5 times 4x squared is negative 20. X squared. Negative 5 times negative 4x is positive 20x. And negative 5 times 1 is negative 5. Okay, let's circle off any like terms. So we have 2 terms, the variable and exponent of x squared. And we have 2 terms that are just plain constant numbers. So we can combine those. Okay, and we know we're finished because if you read this from left to right, there are no more like terms, and our terms are in decreasing order by degree. Okay, for this one I would like you to pause the video and try this on your own. Just be aware of the double set of brackets. So make sure that you go ahead and you distribute the negative 2 first, and then you distribute your negative x by everything after. Okay? Another hint is that this is technically a negative 1. So go ahead, pause the video, try this on your own, and then when you're done, press play and you'll see the full solution and you can check your answer. Okay, very quickly, I want to draw your attention to these 2 scenarios, part A and part B. I want you to ask yourself, what's the difference between the following two expressions? Okay, so hopefully what you realize is in part A, to start simplifying this expression, you would use the distributive property. You distribute that to about everything inside that second set of brackets, 5x and the negative 3. But part B is slightly different. Because you have two binomials or two sets of bracket, you're going to use FOIL. Okay, because everything in this first set of brackets is multiplied by everything in that second set of brackets, whereas above, just the negative 2 is multiplied by everything inside the set of brackets. Okay, so you'd actually use FOIL here, whereas here you'd use distributive property. Okay, we're going to get into some quick word problems. So a cylinder has a radius of 2x plus 1 and a height of 2x minus 1. Write an expression that's simplified for the volume of this cylinder. So it helps to draw out the scenario if you can. So here's a cylinder with a radius of 2x plus 1 and a height 2x minus 1. Okay, so you have to recall the formula for the volume of a cylinder. So it's area of the base shape times height. Okay, so because our base shape is a circle, pi r squared times height. Okay, now let's just go ahead and plug in what we know. Okay, our radius is 2x plus 1 squared times our height, which is 2x minus 1. Okay, now we just simplify this. So 2x plus 1 squared is just 2x plus 1 times 2x plus 1. Let's go ahead and simplify that using FOIL. Okay, now we can combine our like terms. So 2x plus 2x is really just 4x. Now let's distribute the pi amongst everything inside the brackets. So now we have pi times 4x squared is 4 pi x squared plus 4 pi x plus pi, and that's all multiplied by the height. Now we have a similar situation to one of the knowledge questions we did before. A trinomial times a binomial. Just take each term from the binomial and multiply it by each of the three terms in the trinomial. So we'll go 2x times the first term, times the second term, and times the last term. Then we'll do the negative 1 times the first term, second term, and last term. Okay, now let's combine our like terms if we have any. So we definitely have like terms here, and we have like terms here. Okay, so a simplified expression for the volume of this cylinder is written right there. Okay, the last question. The revenue function for the sales of pancakes at a local restaurant is r equals negative 2.2x squared plus 17.6x, and the cost function is c equals 4.4x plus 11, each in thousands of dollars, where x is the number of pancakes made in thousands. So if you sold 1,000 pancakes, you would just plug in 1, because x represents the number of pancakes in thousand. Determine a simplified expression for profit, and then determine the profit if the restaurant makes 4,500 pancakes in one day. So it's two parts. So first let's come up with an expression for profit. And you probably would have done questions that involve profit, revenue, and cost before. So if you haven't, in grade 10, just as a reminder, the way you calculate profit, it's equal to the revenue minus the cost. So revenue is how much you make each day, and then cost is the amount you're spending as a restaurant to get your business going. So basically you take what you make each day, you subtract the cost it took you to get everything started, and then whatever you have left over is your take home, or your profit. Okay, so let's plug in our expression. So what was the formula for revenue? It was negative 2.2x squared plus 17.6x. And whenever you're plugging something in, you want to plug it in brackets. Okay, minus the cost. Our cost formula was 4.4x plus 11. Okay, now let's simplify this. So let's distribute this negative inside of those brackets. Okay, now let's combine our like terms. Okay, so there's our simplified expression for the profit made at this pancake restaurant. Okay, so that's part one of the question done. Part two asked, now use that simplified expression to figure out how much profit the pancake restaurant would make if they sold 4,500 pancakes in one day. So we're basically just going to take our profit equation and we're going to plug in the number of pancakes for X and then see what we get as a profit value. The biggest mistake I see students make is they plug in 4,500 for X, but remember, X is the number of pancakes in thousands. Okay, so instead of plugging in 4,500, we're going to divide that number by 1,000 and we're going to get 4.5. So 4.5 is the number we are plugging in. Okay, and then it's just going through and doing the math. So you're going to take 4.5, square it, and then multiply it by negative 2.2. And you get negative 44.5 plus, okay, 13.2 times 4.5 is 59.4 minus 11. Okay, and then you do the math there, and you get a profit of 3.85. Now some of you might be thinking, $3.85 profit, that sucks. Well, remember, profit is also represented in thousands. Multiply that number by 1,000 to get the true profit. Okay, so actually the profit is $3,850, which is pretty good. All right, so that's the end of the lesson. If you could tackle the homework right now, that'd be great, and feel free to ask for any help on any of these topics.